Hello everybody. It is the end of April 2024 and today I'm going to show you how to create, make and use libraries in your C programming projects. And this is a continuation of the video that I recorded about how to use an integrated development environment, an IDE, and more specifically the CodeBlocks IDE that I already have here running here on the left. And to show you this, how this works, first of all, let me show you just a very small repetition of the previous video, is that how to install this. First of all, we have here in Linux Mint, we can just find it on the software manager, and there we have it. This is CodeBlocks. It is the one with the logo which reminds us of Windows. Well, they will be forgiven for that. For the rest, this environment is working actually quite well, as we will see. And just to remind you why it is so good to use an IDE is that you can run your program step by step, and at every step inspect your variables if you want to see if they have the correct values, if there is something wrong, maybe wrong assumptions. Or you can put breakpoints in your program and let it run until it arrives at that part in your program, and then you can inspect, once again, you can inspect your variables. Or maybe your program doesn't even arrive at your breakpoint, something unexpected, and this will give you more information, and you will do much faster debugging than writing printfs all the time in the middle of your program. So just to show you where we were with the last video, we wound up with this program. It had these two functions, my sum and my trigonometry, my trigon, and these two functions today we're going to put in the library. By the way, we're going to put them here. And these functions were called by the main program. We then compiled it, and there was a problem. The compiling was okay because we included the header file of the mathematical library. And then if we build it, if we compile it, there is no problem. But when we build it and link it, it doesn't know this sine and cosine functions, although we have actually told them exactly where they are, and we have set the header file. This is, of course, a problem, and we've solved it by the build options that, remember, we had to do in the linker settings. We had to say link also with the mathematical library. And for some reason, this is only for the mathematical library. You have to do this specific trick. Now let me clean this. I always have to clean for some reason. And then I can build again. It compiles well, and now it also builds well. So this is where we were. We now run the program, and we see that indeed the program outputs first Ha die Wereld, which is sort of like hello world in Dutch. Then we print the sum. Let me show you this here. The sum of 2 and 3. The 2 and 3 is 5, and the sum of the sine of 0.5 radians and the cosine of 0.5 radians is 1.357008. Well, I will believe him if he promises never again to lie. Okay, this is now the state of where we were. Everything was under control, but now we want to create a library. So what library we're going to use? We're going to create it here in a completely different directory. Just to complicate things a little bit, we're going to put it in another directory, because then we could sort of leave it there and never touch it again until we want to change our library. Okay, just to show you, I have a directory here that's called mylibs. As you can see, it's empty, and let me do everything. This part I will do command line, mylibs, and as you can see, it is completely empty, and we're going to create here now a file, new document, and this file we're going to call mylib.c. We're going to edit it, and we're going to migrate our code that we want to include in our library. So that is this. All this part I'm going to cut out, Control X, and I'm going to insert it here. So far, so good. So now I can compile this. I will show you everything that will go wrong, and I will explain why it will go wrong and what the solution is. So I'm going to compile and say mylib.c. And as you will see, this will not go well, because there we have it. Once again, the same error. It doesn't know the sine and the cosine. Well, we already know the solution. We have to say minus link with the mathematical library. There we go. Still doesn't go well. because it expects a function main. Because when you do standard compilation, GCC, the GNU C compiler, it expects that you're writing a program. And we don't want a program, we want a library. A program needs to communicate with the operating system, needs to receive values, arguments, and needs to communicate and send a value back. So it needs to have an entry point into your program. It needs to have a main. The program starts at the first line of instruction of main. So we don't want that, we just want to compile it into an object, not a program, just a set of code. And for that we have to say -c. And as you can see, now it compiles, and we can also do like this. We now have what is called an object file, mylib.o. You can also see it here graphically. There is a file which is called now mylib.o. That is nice. So we're nearly ready to include this into our program, into our IDE. Once again, this program here is running in my Dropbox file, and this is in my home directory, so it's in two different places. But I can now already include it here. But as you know, to include a library, we need a header file. So let's create here a header file, mylib.h. What do we have to put in this header file? Well, the same, the functions, but only the description of the functions, not the functions themselves. We need to put here, only specify that when our compiler is finding these functions, that he knows what kind of arguments the function expects and what to expect. The function will return, what type of value the function will return. It doesn't need the code, it only needs to know what it is actually. Doesn't have to know what it's doing, it only has to know the way how to communicate with these functions. What are the arguments and what is the value that is returned. So we have this now, we're all ready. We have our code, we have our compiled code, and we have now our header file so that we can use this. Did I save this one? Yes, I saved. Now we can include this into our project, into our program, which has the main. And now, of course, how do we do this? You know, include hashtag, no, it's called pound, I think. Pound. Hashtag is that modern thing. Include, and now we don't put the include into this smaller and larger signs, but we put them now into quotation marks because it's not part of the standard library, but it's our own library, and we say mylib.h. I save it. I have to clean this one again, I always have to do this, and now I will say build. Okay, it is an error because it doesn't know where to find it, because I didn't put these files into the directory where this file also is, which is on the Dropbox. Remember the video of yesterday? It is somewhere completely different, so I have to specify to the compiler where it can find it. Once again, I go to build options and I say here search directories, and in the search directories I have to specify actually where it can find the header files, and that I have to do here. I have to search home, mylibs, and in mylibs there are the files that this is the correct directory, these files are these files, and I can say open, and I say no, keep this as a relative path. I say no, because then I will be able to, if I use an absolute path, I will be able to move my project to a different part of the disk and it will still actually compile well. Okay, so far so good. Let me clean this one again. Clean, always clean, otherwise this video will go a little bit strange. Build, I can compile, yes, now it finds my header file, and I would be able to build, compile, and link. No, it didn't find this my sum and my trigonometry, because it only knows that they exist, but it doesn't have access to them yet. So not only do I have to say to the compiler where the header file is, but also to the linker where the actual code, the object, is. Once again, there we go, build options, and now we have to say in the linker settings, here we have the link libraries, and I can add this one, hopefully. Oh, in mylibs, although the files are there, the object is there, it is not here, because it has to be of the type shared object, and this is just a normal object. If you want to create a library, you have to have a shared object. This is how it works nowadays. So I have to compile this one and to make it into a shared object. How do I do this? Well, I will say gcc, and now not -c, but -shared. And what do I want to compile? mylib.o, and let me put the output file -output mylib.so, so that it can actually compile it correctly, and it has made a mylib.so, and this is what it expected here. Remember? So let me go here again, build options, linker settings, linked libraries, add, and search for it. Yes, there it is, mylib. So this is the one. This I want to use as my library. Once again, I use absolute path. You can also use a relative path for these small things. It doesn't even matter so much. So now let me clean this one, and let me build. It still compiles, and now it also links. So now we have everything. To show you how funny this is, well, this one is actually not needed anymore. And this one I can now actually remove the sort. Let me put it here on the desktop. I can put it here on, and I can completely remove it. The only thing this needs, to show you that this works, clean this, I only need the header file for compilation and the shared object for the linking. Let me show you this. Compile, it still compiles, and to build, it compiles and links. So the only thing we need is the header file, the description of the functions, plus the compiled library. This is very interesting that I can just show what my functions do. I can actually have them, the functions themselves are there, but I don't have to share to anybody my source code. This is not needed. I just need the header file and the compiled code. Then it will already run. Just to show you that it runs, let me show you now here. We run it, and we have again the exact same functions here. Functionality, we have again HD Wereld 5 and 1.357008. And as you can see, this is sort of like hidden. It's in a different part of my disk, and I have it here, include my library here in this in my project. Now this of course is already basically what I was going to tell you, but you might come into problems a little bit later on if you want to use also global variables. Well, this is not advisable, but maybe one day you will still want to do this. And now imagine that, let me put this one back here so that I can show how this works. Now let me see, for instance, that we have this one, and imagine that I want to put here a global variable, and I will show you why it goes wrong, and I will explain why it goes wrong. And I will put here, for instance, my double, and I will put here also always initialization is always good, initialization, and maybe I use it here plus my double. Imagine that I have this kind of situation. I have a global variable that is part of my library. I can compile it again, compile my library. Now it again created the object file here. Again, compile that object file into a shared library, and now it gives me an error that it's saying something recompile with FPIC. My double cannot be used when making a shared object. Yes, the problem here is that this is called this is a problem of the computer architecture. I cordially invite you to also see my series of videos about the computer architecture. The problem here is that if you use global variables, they can be in a different place of memory than your functions and then your local variables. Local variables are on the, for instance, they can be on the stack, and your global variables, maybe they're somewhere on the heap, or at least they can be far away in memory, and then you need what is called a large memory model compilation. Because they're not basically not on the same page, they're not close by, so you need different memory addressing. How to do this? Well, apparently what this compiler is saying, to have that, to force this large memory model, you have to do -FPIC. C. So, okay, let's do that. Let's do -fpic. Not sure what it stands for. Yesterday I read it somewhere, but I already forgot. And then we can actually, my double cannot be used. Oh no, sorry. I have to put, of course, I have to do this already here. I already have to use this -fpic, and then that goes well. And now I can also use, we have a new object file, and now this new object file I can also convert into a new shared object file. And of course, we also have to now include this into our header file. We have double my double. Yes, there we go. And we can now clean this one. We go back. Oh, this one is still running. That was not needed. I clean this one. I compile it again. Compile, that goes well. And I build it. That goes well. And let's now use our local, our global variable, and my double is, let's put a big value to show that it works. My double is 100. Build, compile, yes, build and link, compile and link. And now let's run it. And as you can see here, now the sum of the cosine and cosine plus my global variable of 100 is now 101.357008. So far so good. I'm going to complicate a little bit even more. I'm going to now also use a string variable. And I found out that also this is actually not so easy. Imagine that I put char my string equals, and now let me put it in something in Portuguese. I have to put it here, Portuguese keyboard. Olá mundo. This is Portuguese. And let me go back to the American keyboard. I want to close this, and I would be able to put this also here. But yes, this is not the way how to do it, because now we will have it 2 times defined, 2 times shared on the same space. So now I have to just say like this. And also this actually doesn't work. Let me put it like this. Here everything goes okay, no problem. But I guess now here, I hope that now I can show this, that here it goes wrong. Clean, build, compile. There is exactly. My string assumed to have 1 element. And now I will show you, we'll get a segmentation fault. That would be the equivalent in the old times of Windows. This would be the blue screen of death. And it will show, what am I doing here? Oh, this is actually already to have 1 element. Well, build, compile it done, build, that's okay. But actually you will see now that it will make a, no, I was going to, of course, I must use it in my, function, and then I will get a segmentation fault. Printf %s string new line. What did I have it? My string, wasn't it? My string. Clean this one, clean, build, compile. My string assumed is a warning. It's a warning. It already tells me a warning. Yes, warning. Well, warnings we ignore, don't we? We build it, and now we run it, and we get, there's nothing. There was actually, it is just a one that we sort of seem to have 2 objects. One is here in our factual library, and the other one is another variable which is in my heading file. And to avoid that there are 2 versions of them, I can use here for this, I will have to use in my lib, I will have to use external. Am I now doing this in the correct place? I hope so. Yes, it's there. It's in this one. I should not edit this one in my environment. This is just in a normal editor. You can see here, I'd use here that is external, and it points to this. This one is now actually points to this string. And this will just, let me put this, I just now do this always external file. Let me compile this one. Now again here nothing goes wrong, and make it into a shared object. Yes, nothing can goes wrong. I can again move this one and this one. I can move here to the desktop. No problem. I could here stop the execution of this one, clean it, build, compile, nothing going wrong, build, it doesn't complain anymore, and I can run it, and as you see here now it says Hola Mundo. So this is just some extra peculiarities at the end of this building of your libraries. Well, I hope you enjoyed this video, and with this you can probably very nicely write your own libraries, put them in a separate part of your disk or give them to your friends. Don't give away your code, of course. It was hard to write, so they should also suffer if they want to have the same. Just give them the header file and the shared object, which is the library, and then it can be compiled, can be used in your integrated development environment. Okay, see you in the next video one day.